Hello guys, welcome to next video of this playlist Python for beginners. Currently in this playlist we are exploring OpenCV basics, and in last video we are successfully understand what is thresholding technique that is using OpenCV. Now in this video we will be exploring another concept of OpenCV, which is adaptive thresholding. For that, let's move to our destination folder. So this is our destination folder, as you can see. Now I will simply open this folder in VS Code. So as you can see, the folder is open in VS Code. Now I will open today's file, which is exactly the same that I have taught you in last video. Now let's just zoom in for you. And this was the code of last tutorial that I have explained you. Now I will just remove unwanted part to save our time. So this is the basic code that I will explain you within 30 seconds. So first is importing of CV2 package, loading the image, and this time the image name is different. So I will simply type here image name, which is pseudocode.png, and next line is same, which is CV2.threshold image 127 to 55. So this is the thresholding value, this is the maximum value, and this is the method, which is thresh binary. Then displaying the output, as you can see, along with th1. So let's make it th1. This is done, and last two windows for closing the OpenCV window. So I hope the code is clear to you. Now in this video I want to tell you that this CV2.threshold method only works for a grayscale image. Means if you pass image which has multiple colors in it, then normal thresholding will fail. I will show you the output of this pseudocode.png, then I will explain you the reason. So I will simply run the code, as you can see. So let's wait. So this is the normal image, and this is the output of image thresholding. And as you can see, the half part of image is black, and due to these characters are not identified, which is 76874. So this entire part is made black, and the output is very poor of normal thresholding. So in such situation, adaptive thresholding comes in picture, which calculates the threshold for smaller section of an image, which means the adaptive thresholding methods calculates the pixel value for smaller region based on our choice, which means adaptive thresholding for this part will be different, adaptive thresholding for this part will be different, and so on. And the area is also predefinable, which means we can select how much area should be cropped or changed based on the pixel values. Now let's implement the code to see the output of adaptive thresholding. So I will simply close these two windows and let's declare adaptive thresholding. So let's keep variable name as cs2 cv2 dot spelling adaptive thresholding. So the spelling is adaptive thresholding, and it takes different parameters. So first parameter is image itself, which is this. Second parameter is the maximum value, which is 255. So I will simply enter 255, which is the value cannot go above 255. And next is the adaptive thresholding type. So I will be simply using cv2 dot adaptive threshold or thresh underscore mean underscore c. So this is the method name, which is adaptive thresh mean c. And next is threshold type. So threshold type will be same that we used in last video, which was cv2 dot thresh binary. Don't worry, I will explain you this line once again if it's not clear to you. After that, the last two parameters are the area which you want to apply this adaptive threshold. So let's make it 11. And next is the default argument, which is c. So c is normally a default parameter which is used to subtract the data from this adaptive thresholding mean. So it's a default argument, and normally we keep it to only. So this is the method which is used to perform adaptive thresholding. Now let's print or see the output. So I will simply duplicate this line by clicking Ctrl D, and let's change the name from th1 to th2 and also the type. Now let's run this code to see the output. So let's wait. So it's giving me error that CV2 has no attribute adaptive thresholding. And actually the name is adaptive threshold and not thresholding. Now let's run the code once again to see the output. And as you can see, we are getting one more error, which is assertion fail. So this error normally occurs when the input is not correct or the input is not suitable to this adaptive threshold method. So the reason this error has occurred because this is somehow colorful image. So let's convert this image to black and white. So the method to convert the image is cv2.imread grayscale. So which will directly read the image as grayscale only. Now let's run the code once again to see the output. So this is the output. So this is the output of th1. This is the normal image, as you can see. So this is somehow better and it has identified all numbers correctly as compared to this th1. There is another method which is called as adaptive thresh Gaussian. So let's test that method also. So I will simply just replace this main with Gaussian. I hope the spelling is correct. Let's make it 3. And I will simply remove normal output. So this is the output of adaptive threshold Gaussian and this is output of adaptive thresh mean. Now let's run the program to see the output. So this is output of adaptive thresh mean and this is output of adaptive thresh Gaussian. So there is no bigger difference, but it looks that adaptive threshold mean identify the text and makes it bold as compared to adaptive thresh Gaussian. So adaptive thresholding is used where normal thresholding fails. In this video, we have learned about what is adaptive thresholding, what is the importance of adaptive thresholding, and why normal thresholding fails in various image cases. And also normal thresholding only works on grayscale type of images. So that's all for today's video. If you like this video, then don't forget to share it with your family and friends. If any queries while running the code or anything that you have not understood, feel free to comment down or connect with me on Instagram. I will be happy to answer you all. Also, the source code of today's video is available in video description. You can definitely check out that. Here comes the end of this video. Thanks for watching this video.